Good morning, students. Today we will discuss about multiplicative inverse of a complex number. What is multiplicative inverse? Multiplicative inverse are reciprocal for a number x is denoted by 1 by x or x inverse, which when multiplied with x gives multiplicative identity 1. That means if you multiply any number with multiplicative inverse, that gives identity 1, multiplicative identity 1. For example, let us take 6. The multiplicative inverse of 6 is 1 by 6. Since the product of these two numbers gives 1, multiplicative identity 1. So 1 by 6 is called multiplicative inverse of 6, or 6 is called multiplicative inverse of 1 by 6. That means these two are multiplicative inverses to each other. 1 6 and 1 by 6 are multiplicative inverse to each other. Similarly, in case of complex number z, if you multiplied z with 1 by z, it gives 1. In this case, 1 by z is called the multiplicative inverse of z. This 1 by z can also be represented as, that is denoted as z inverse. Let us take z is equal to a plus ib be the complex number. Multiplicative inverse of z is equal to, multiplicative inverse of z is equal to 1 by z, or it can be denoted as z inverse, which is equal to 1 by a plus ib. 1 by a plus ib is not in the form of complex number. That means our standard form of complex number is a plus ib. Here in the standard form there is no imaginary part in the denominator. Only we have imaginary part in the numerator. So to remove the imaginary part in the denominator of the multiplicative inverse, we should rationalize the denominator. Rationalizing the denominator, we should multiply a plus ib with the conjugate of a plus ib. What is the conjugate of a plus ib? Conjugate of a plus ib is a minus ib. A minus ib is multiplied with the numerator as well as with the denominator to balance our original fraction. That implies z inverse equal to a minus ib by a square minus ib whole square. This is because the product of a plus b into a minus b is a square minus b square. By using this algebraic identity, you can multiply a plus ib into a minus ib as a square minus ib whole square, which implies z inverse equal to a minus ib by a square minus I square into b square, I square into b square. Now, which gives z inverse equal to a minus ib by a square plus b square. Since the value of I square is minus 1, since the value of I square is minus 1, minus and minus 1 gives plus. That is equal to z inverse equal to a by a square plus b square minus I into b by a square plus b square. Here the denominator is separated to both the terms in the numerator. So we get z inverse equal to a by a square plus b square minus I into b by a square plus b square. Here it forms the real part and it forms the imaginary part. Now it is in the form of standard form a plus ib. Standard form a plus ib. Now z inverse equal to a by a square plus b square minus I into b by a square plus b square. We can also find multiplicative inverse using this formula. Z inverse equal to conjugate of z by mod z whole square, which is equal to a minus ib by square root of a square plus b square whole square. We know that what is the conjugate of z? Z is equal to a plus ib. So conjugate of z is equal to a minus ib. So conjugate of z equal to a minus ib by modulus of z means modulus of z is equal to square root of a square plus b square. So mod z whole square means root a square plus b square whole square, which gives a minus ib by a square plus b square. By observing the above value, z inverse equal to a minus ib by a square plus b square, and our formula value z inverse equal to a minus ib by a square plus b square. Both the results are same. So we can able to find the multiplicative inverse by using this method or also by using this formula. That means you can calculate the multiplicative inverse of any complex number by using two ways. First one is rationalizing method and the second one is formula method. Let us take an example. Z equal to 7 minus 2i. Z bar, that means conjugate of Z is equal to 7 plus 2i. Simply change the sign of the imaginary part. So you will get 7 plus 2i. Now modulus of Z is equal to square root of a square plus b square. A means real part of the complex number and b means imaginary part of the complex number. So modulus of Z is equal to square root of 7 square plus minus 2 whole square, which gives square root of 49 plus 4, that is equal to square root of 53. Modulus of Z whole square is equal to square root of 53 whole square is equal to 53. Now find out the Z inverse in first method, that means rationalizing method. Rationalizing method. Z inverse equal to 1 by x, 7 minus 2i. 7 minus 2i is in the denominator. That means the imaginary part is in the denominator. To remove this imaginary part, you should multiply 7 minus 2i with the conjugate of 7 minus 2i. What is the conjugate of 7 minus 2i? 7 plus 2i. Conjugate of 7 minus 2i is 7 plus 2i. Multiply this 7 plus 2i with one numerator and also denominator. Now it gives 7 plus 2i by 7 minus 2i into 7 plus 2i. Here it is in the form of a minus b into a plus b. So a minus b into a plus b gives a square minus b square. 7 square minus 2i whole square. That implies that is equal to 7 plus 2i by 7 square gives 49 minus 2i whole square gives 4i square. That is equal to 7 plus 2i by 49 minus 4 into minus 1. I square value is minus 1, which is equal to 7 plus 2i by 49 plus 4, minus of minus plus 4, which is equal to 7 plus 2i by 53. That means Z inverse is equal to 7 by 53 plus I into 2 by 53. It is the multiplicative inverse of Z. Now using the formula, given Z is equal to x 7 minus 2i, mod Z is conjugate of Z is equal to 7 plus 2i and modulus of Z is equal to root 53. In the first itself you find what is mod Z. So mod Z whole square is equal to root 53 whole square. Now the formula of multiplicative inverse is Z inverse equal to Z conjugate by mod Z whole square. What is Z conjugate? 7 plus 2i. 7 plus 2i by square root of 53 whole square. Modulus of Z is equal to square root of 53. So square root of 53 whole square, which is equal to 7 plus 2i by 53. Now separate the real part and the imaginary part. 7 by 53 plus I into 2 by 53. So observe the values of inverse in two methods. Z inverse equal to 7 by 53 plus I into 2 by 53. Here by using formula Z inverse equal to 7 by 53 plus I into 2 by 53. So we can use either rationalizing method or formula method to find the multiplicative inverse of any complex number. Let us take another example. Z is equal to 5 plus 7i. By using rationalizing method. By using rationalizing method, Z equal to 5 plus 7i and 1 by Z. Z inverse or 1 by Z is equal to 1 by 5 plus 7i. It can be multiplied with the conjugate of the denominator. So conjugate of 5 plus 7i is what? 5 minus 7i. Conjugate of 5 plus 7i is 5 minus 7i. You can multiply denominator with the conjugate of denominator 5 minus 7i. That is multiply 1 by 5 plus 7i with 5 minus 7i by 5 minus 7i. To balance our original fraction, you should multiply 5 minus 7i with the numerator as well as with the denominator, which is equal to 5 minus 7i by 5 plus 7i into 5 minus 7i. That is equal to 5 minus 7i by a plus b into a minus b. This is in the form of a plus b into a minus b. So a plus b into a minus b gives a square minus b square. Here a square is 5 square minus b square is 7i whole square. That is equal to 5 minus 7i by 5 square gives 25 minus 7 square means 49 and I square. 49 I square. Now 5 minus 7i by 25 minus 49 into I square value is minus 1. That is equal to 5 minus 7i by 25 minus of minus plus 49. That is equal to, that implies Z inverse equal to 5 minus 7i by 25 plus 49 gives 74. Now Z inverse equal to 5 by 74 minus 7 by 74 into I. Now it is in the form of a plus ib. 5 by 74 makes real part and minus 7 by 74 makes imaginary part. Now we can use formula method to find the multiplicative inverse. Let Z inverse equal to Z bar by modulus of Z whole square by using formula method. What is Z? Z is equal to 5 plus 7. Z equal to 5 plus 7. 5 plus 7. Now, what is conjugate of Z? 5 minus 7. What is modulus of Z? Square root of a square plus b square. That is equal to square root of a square means 5 square plus b is minus 7 whole square. That is equal to 25 plus 49. That is equal to 74. Now, by using formula Z inverse equal to conjugate of Z by mod Z whole square. That is equal to, what is conjugate of Z? 5 minus 7. 5 minus 7i by, what is mod Z? Square root of 74 whole square, mod Z whole square. That is equal to 5 minus 7i by square root of 74 means 74. That is equal to 5 by 74 minus 7 by 74 I. Now observing both the values you obtained Z inverse equal to 5 by 74 minus 7 by 74 I. Here by using formula you got Z inverse equal to 5 by 74 minus 7 by 74 I. These two values are same. So you can use either formula or rationalizing method to find multiplicative inverse of any complex number. Thank you.